Hi guys, today we are going to talk about representing linear non-proportional relationships. All right, so first of all, what is a linear non-proportional relationship? Well, let's just break up exactly what the words are saying. All right, so first thing is write in that first word, linear. What does linear mean? Well, I see the word line. Linear means that your data will make a graph, or sorry, the graph of your data will make a straight line. Okay, so graph will make a straight line. Okay, the second thing is it says non-proportional relationship. Okay, we talked about non-proportional relationships and we talked about proportional relationships. If something is proportional, remember it has to make a straight line and it has to go through 0, 0. So a non-proportional relationship, okay, it makes a straight line. So the part that's going to make it non-proportional is this time it will not go through 0, 0. Okay, does not go through 0, 0, does not pass through the origin. Okay. All right, so that is a linear non-proportional relationship. Makes a straight line, but does not go through 0, 0. All right, we are going to look at an example of a non-proportional relationship. And we're going to break it apart. We're going to get some data points and we're going to graph it. Okay, it says the equation y equals 2x plus 5 gives the total height y of a plant in an experiment that was 5 centimeters tall at the beginning of the experiment and grew 2 centimeters each day. Make a table of values for this situation. Okay, now remember, when we are looking at our table of values, we have our input values or our x values and our output values or our y values. Okay, I also talked about the input being the independent variable and the output being the dependent variable. Okay, so this data is keeping track of how tall a plant is after so many days. And now when we look at our variables, this makes sense, okay? If you don't know how many days have gone by, you cannot calculate the height of that plant. Okay, so in order to figure out the height of the plant, you must know the number of days. So the height depends on the number of days that have gone by. Okay. All right. So in our equation, y is the total height. All right. And we calculate the total height by doing 2 times x. And remember, x is your days. So you're going to do 2 times the number of days plus 5. Okay. All right, so what we're going to do is we're going to see how tall this plant is after 1 day, 2 days, 3 days, and 4 days. All right, so in order to figure out how tall the plant is after 1 day, we are going to plug in 1 in for x in our equation. So I'm going to think 2 times 1 plus 5. All right, so 2 times 1 is 2 plus 5. The plant will be 7 centimeters. Okay, we're going to do the same thing for 2 days. So 2 times 2 plus 5. So we're going to get 4 plus 5, 9. After 3 days, 2 times 3 is 6, plus 5 is 11. After 4 days, 2 times 4 plus 5, that's 8 plus 5 is 13 centimeters. Okay? All right, so now we have a couple of data points. Right here, it says, in the equation, y equals 2x plus 5, what could the 5 represent? All right, so let's think about this. We know y is the total height. We know x is the days, and we're taking the days and we're multiplying it by 2. Why? Because in our word problem, it said that it was going to grow 2 centimeters every day, each day. So 2 times however many days have gone by. All right, well, what's this plus 5 then? Well, let's read back. It says, the total height y of a plant in an experiment that was 5 centimeters tall at the beginning of this experiment. Okay, so right there, it's telling us that that 5 is actually how tall the plant was initially. Okay, it was 5 centimeters to start with before we started keeping track of its growth over days. So how tall the plant was initially. Okay, so if that's how tall it is initially, this is also how tall it was at the start, or 0 days that we've been keeping track. Okay, and this is going to be really, really important when we start explaining the different parts of our equation. All right, so now what I'm going to do is we are going to graph our data. All right, so if you hit this little circle with the square, you'll get lines. So I am going to draw in my x and y axis. Now for this particular problem, because I am dealing with centimeters or a measurement, a distance, that can only be positive. And because I'm talking about a time, that also can only be positive. So our x and y values are both positive. So we're just looking at the first quadrant. Okay, when you are graphing, we're going to draw our x and y axis. You need to label your x and y axis. So my x is representing the number of days. My y is representing the height in centimeters. Okay, the next thing I need to do is put a scale on my graph. I have to show what each line is representing. Okay, so remember, right here is 0, 0. The x coordinate is 0, the y coordinate is 0. When I look at my x values, it goes up to 4, okay? This is a line graph, so remember, you are labeling the lines, okay? Not spaces, lines. Now, I want to spread my graph out a little bit. So instead of having each line worth 1 day, I'm going to stretch it out. I'm going to count 1, 2, 3, 4 lines, and I'm going to say that represents 1 day. And then I'm going to go 1, 2, 3, 4. Now that's 2 days. 1, 2, 3, 4. That's going to be 3 days. 1, 2, 3, 4. That's 4 days. Okay, now that's going to stretch the graph out a little bit. All right, now for the y, the highest y value in my table is 13. So let's see here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so I can have each line be worth 1, but I don't want to label every single line. So I'm just going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay, now that everything is labeled, I am ready to graph. So the first point in my table is really 1, 7. The x coordinate is 1, the y coordinate is 7. So remember, to plot this point, I am going to start at 0, 0. The x coordinate, I am going to read over to the right to positive 1. The y coordinate is 7, so now I'm going to read up 1, 2, 3, 4, 5, 6, 7. And that is the first point that I'm going to plot. That's 1, 7. Okay, the second point 29. So again, I start at 0, and I'm going to go to the right where x is 2, and then I'm going to read up all the way until I get to where y is 9. Okay, my next point, 311. So I go to the right 3, and now I'm going to go up to 11. And then 413. I go to the right 4, and then I go up 13. Okay, if you have calculated your data correctly and plotted the points correctly, your points should form a straight line. Okay, so I'm going to connect my points using that line tool. Make sure you put an arrow on the end because this data will continue on. Our days can keep going. And then the last thing that you need to do whenever you're graphing is make sure you label with the equation that was used to graph that information. Okay? And that would be the graph of our data. All right, is the relationship between the height and the days proportional? Okay, so remember the first two things that we wrote down. If something makes a straight line and it does not go through 0, 0, then that will be considered non-proportional. So I would say the data is non-proportional. Okay, it does not go through 0, 0. That's why it's proportional. So the line does not pass through 0, 0. Okay. All right. The next example, you may want to pause the video and try the next one out on your own, and then you can go back and replay and check your work. If you are stuck, then just continue playing the video. Follow along. You may have to pause and flip back and forth because I know you guys are trying to take notes as you are watching this. Okay, so let's take a look at this example. A medical delivery service charges $10 for a house call plus $2 per mile. The situation is represented by the equation y equals 2x plus 10. All right, so the first thing I need to do is I am going to have to figure out, well, what is my x representing and what is my y representing? Okay, so if I go back, it says a medical delivery service charges $10 for a house call, okay, plus $2 per mile. So I'm doing 2 times the miles. So right here, it looks like my x is going to be miles. Well, what's the y? Okay, we're talking about how much the delivery service charges. So my y would be the total cost. Okay. All right. Now let's get some data. All right. So if the delivery truck delivers something 1 mile away, 2 miles away, 3 miles away, and 4 miles away, what would those costs be? All right. Just like the last one, to figure out the cost for 1 mile, I'm just going to plug in 1 for x and solve that. So it would cost $12. Okay. For 2 miles, it would cost $14. For 3 miles, $16. For 4 miles, $18. Okay. All right. It says in the equation y equals 2x plus 10, what could the 10 represent? So I'm going to go back up to my word problem. It says a medical delivery service charges $10 for a house call. So the 10 represents the amount that you have to pay for the house call. And that's before you even factor in the money per mile. Okay, so it's $10 initially, no matter what. It's just $10 for the initial house call. Okay. the initial, there's only one L, the initial charge for the house call, okay? And this is the cost for 0 miles or at 0 miles, or for cost for a delivery 0 miles away. Okay. All right, so we are going to graph this data. Again, I got to draw in my X and Y axis. I'll use green this time. Okay, there's my X axis. There's my Y axis. Put some arrows on it. Again, I'm just looking at that first quadrant because I'm talking about positive values. You can only have positive miles, and the cost will be a positive cost. All right. I'm going to label X and Y. My X is representing the miles. My Y is representing the cost. Okay, again, my miles go up to 4. So I'm going to spread it out just like I did in the last one. 1, 2, 3, 4. That's going to be 1 mile. 1, 2, 3, 4. That's 2 miles. 1, 2, 3, 4. 3 miles. 1, 2, 3, 4. 4 miles. Okay. Now this time I need to make it all the way up to 18. Now this is the same grid as the last problem, and I know there are only 14 boxes. So what I'm going to do is I'm going to have each line be a value of 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 22, 24, 26, 28. Okay. All right. Now I'm going to graph my points. So I have the ordered pair 1, 12. So I'm going to go to the right one and I'm going to go up to 12 and plot that point. Then I have 2, 14, 3, 16, and 4, 18. And again, if I calculated my data correctly and I plot the points correctly, I should be able to draw a straight line right through the middle of all those points. Whoops. And I can. All right, the last thing I'm going to do is label my line. Y equals 2x plus 10. Is the relationship between the cost of delivery and miles proportional? And explain. I'm going to say no, it's not proportional. Again, just like the last one, it did not go through 0, 0. So the relationship is non-proportional. The line does not pass through 0, 0. Okay. All right, we're going to keep on going. All right, the next 3 examples. These I think are actually easier than the word problems because you are already given your equation, and all you're going to do is plug in your x values into the equation to find 5 points that would be on your graph. You're going to plot the 5 points and then connect them with a straight line. Okay, they're very straightforward. All right, these, they're not going along with the scenario, so we are going to use positive and negative values. So now you're using all 4 quadrants when you are graphing your line, okay? Now, for these examples, I have given you 5 x values. You technically could pick any numbers you want for x, plug them into the equation, plot those points, and you're going to get the same line. You just may get a different section of the line, depending on what x values you were using. All right, so let's take a look at this. If I want to graph the equation, y equals 3x plus 1. So I'm going to plug in -2 for my x value. I'm going to solve it. I get -6 plus 1 So my y value is negative 5. Do the same thing for when x is negative 1. I'm going to plug in negative 1 for x. I'm going to do the math, and that means my y will be negative 2. I'm going to plug 0 in. So 3 times 0 is 0, plus 1 is 1. Plug 1 in. 3 times 1 is 3, plus 1 is 4. Plug 2 in. 3 times 2 is 6, plus 1 is 7. Okay, now we're going to plot these points. So remember, this is the ordered pair, negative 2, negative 5. So I'm going to start at 0, 0. I'm going to go to where x is negative 2, and then I'm going to read down until I get to where y is negative 5, and I'm going to plot that point. All right, next point is negative 1, negative 2. So I'm going to go to the left to negative 1, go down to negative 2, and plot that point. 0, 1. So I go right and left 0, I go up 1. 1, 4. Go to the right 1, go up to 4. And 2, 7. So I'm going to go to the right 2, and 7 is actually going to be up above the graph a little bit. It goes off the grid. Okay, now I'm going to take my straight line, and I'm going to draw a line that goes right through those points. And remember, this line, we're just looking at a section of it when I use these 5 points. This line actually goes on forever. Okay, I could put negative 3 in for x, and I would get a point down here. This line keeps going. All right, the last thing is to label it. Okay. All right, let's take a look at the next example. So be careful with this one. Negative is part of the equation. So when I'm solving for my y value, when x is negative 2, I want to think negative, and now I'm substituting in negative 2 for x, minus 2. So here I actually have a double negative. Negative, negative 2, it will become positive. So now I have 2 minus 2, so my y value would be 0. Okay, negative 1. So negative is part of the equation. I'm plugging negative 1 in for my x value, minus 2. Again, I have the double negative, so that equals positive 1, and 1 minus 2, I get negative 1. Negative 0 minus 2, that's just going to be negative 0. And then here I have negative as part of the equation. I'm substituting in positive 1 for x, minus 2. So this is really saying negative 1 minus 2, I get negative 3. And then negative 2 minus 2 would be negative 4. Okay? All right, we're going to plot these. So my x, I go to the left to negative 2, and then I'm going to have a y coordinate of 0. So it's going to stay right where it is. All right, negative 1, negative 1. Go to the left to negative 1, go down to negative 1. 0, negative 2. Positive 1, go to the right 1, down to negative 3. Positive 2, negative 4. And there we go. All right, I am going to connect my points with a line. And put some arrows on the ends and label it y equals negative x minus 2. Okay? Alrighty, last example. So we're going to use the values negative 4, negative 2, 0, 2, and 4. Now notice these are different than what we have been doing before. Before we were doing negative 2 to positive 2, going up by ones. Like I said, you can technically use any numbers for your x values. Okay? Now the reason why this one is changed to negative 4, negative 2, 0, 2, and 4 is because look at what we're multiplying our x value by, a fraction. So using negative 4, negative 2, 2, and 4, you will end up with a whole number because you're using these even numbers, okay? When you multiply by a half, you'll get a whole number, and then that way we don't have to plot points that are in the middle of the grid. All right, so plugging in negative 4, I'm going to think negative a half times negative 4 minus 3. So negative 1/2 times negative 4. Negative times a negative is a positive, and then half of 4 is 2. So now I'm going to do 2 minus 3, which is negative 1. All right, let's do that for negative 2. So negative 1/2 times negative 2 minus 3. Again, a negative times a negative is a positive, and then half of 2, you'll get 1. And now I'm going to think 1 minus 3, negative 2. Okay? Negative 1/2 times 0 will be 0, minus 3, you get negative 3. Negative 1/2 times 2, you get negative 1, minus 3 is negative 4. And negative 1/2 times 4, we get negative 2. Negative 2 minus 3 is negative 5. And you guys can put this in the calculator to get your y values. Okay? All right, let's plot these points. So the x is negative 4, so I'm going to go to the left negative 4. Y is negative 1, so there's my first point. Negative 2, negative 2, there's my second point. 0, negative 3. Positive 2, negative 4. And positive 4, negative 5. So there's my 5 points. Whoops. And I'm going to connect them with a straight line, put arrows on it, and label y equals negative 1/2 x minus 3. Okay? All right, that's it for the notes, guys. Rewind, pause where you need to, but get these notes jotted down, and then you should be able to work on your homework. Any questions you may have, bring them to class, and I will